Let's now take a look at how we find where a quadratic line and a linear line meet. Now, in this question here, it's asked me to find the coordinates of the point or points of intersection of the graphs with equations y equals x squared take x take 18, which is my quadratic, and y equals x take 3, which is my linear line. Now, before I start solving this question, I just want to consider the three situations that could occur when we're trying to find where a quadratic and a linear line meet. The first situation that we've got is if we've got our quadratic and our linear line that cuts through like this. If we've got this situation here, it's got two clear points of intersection. Now, not that we're going to look at it in this video, we'll look at it in another video, but if we were to look at, when we're solving this, what the discriminant would be, we would find that our discriminant has to be greater than 0 for it to have 2 points of intersection. Useful for a future video. But a second situation that can occur between my quadratic and my linear line is for it to just touch like this. So if it touches like this, we have 1 point of intersection. And if we've got this situation, we're solving our quadratics and we had a look at the discriminant, we would find that our discriminant is equal to 0 instead. Once again, something that we're not going to look at here, but useful for a future video. The third situation that could be occurring here is we could have our quadratic and our linear line that never intersect with each other. So in this case, there's no points of intersection. And if we were to look at our discriminant when we're solving it, it would be less than 0. Now, the reason why I've illustrated this for this video is simply because we need to determine what the point or points of intersection are. So we need to be aware that when we go to solve this, we could be finding a situation where we're looking at two different sets of coordinates for our 2 points of intersection. We could be looking at a situation where it only ends up intersecting once, there's only one solution. And we could also end up with a situation where we can't solve it. And if we can't solve it, it's indicating to us that there's no points of intersection between these two lines. So moving on to actually solving this question. Basically, when we're trying to solve these equations, we're going to solve simultaneously by using our substitution method that we use when we're doing this with linear lines. So essentially, if I consider this my y1 and my y2, I want to know when my y values in each equation are the same. So essentially, I want to know when my y1 is equal to my y2. And from here, I can substitute what y1 actually is and what y2 actually is. So my y1 is x squared, take x, take 18, and that's going to be equal to my y2 of x take 3. From here, I've now got a quadratic that I can solve, and I use my solving quadratic step by step to do this. The very first step is I need to make this equal 0. So I need to bring the x and then take 3 onto the other side. So this will end up being x squared. Take another x will be take 2x. Add 3 will be take 15 overall. And that now equals 0. The second thing I should do is check for any common factors that might exist between here. In this case, I don't have any common factors, so I'm going to see whether I can factorize it. If I can't factorize it, I should use a different method of solving, such as the quadratic formula. But in this case, I can see that this will factorize, and to get my sum of -2, my product of -15, it will need to be -5 and +3. So now I've got my null factor law. I've got a number multiplied by another number that equals 0. So my solutions to this, either this part has to equal 0 or this part has to equal 0. So either my x take 5 must equal 0, so my x would have to be 5 here, or my x plus 3 would have to be 0, so that would need to be -3 to make that 0. So now, I've determined where the x coordinates are of the points of intersection. Because I've got two of them, it means I've got this situation here where there's 2 points of intersection. However, I need to find the coordinates of the points of intersection, not just the x coordinate. So what I do is I substitute these back into either one of these equations. I'm obviously going to pick the linear equation because it's going to be simpler, but you can use the quadratic equation if you wish. So the first thing I need to do is look at when x equals 5, my y is going to be 5 take 3. So therefore my y is going to be equal to 2 and my coordinate's going to be 5, 2. When my x is equal to negative 3, my y is going to be equal to negative 3 take 3, which is equal to negative 6. So therefore my points of intersection are this 5, 2 and this negative 3, negative 6. So in summary, if we're looking to find where the point or points of intersection may occur between a quadratic and a linear line, it can either have 2 points of intersection, 1 point of intersection, or no points of intersection. We've got to keep that in mind. But what we want to do with our equations is we want to simultaneously solve them. So we're essentially trying to find where y1 and y2 will equal each other. We substitute it in and we solve that equation using our solving equation techniques through factorization or completing the square or quadratic formula or something like that to determine what the x values of our points of intersection would be. Once we've got them, we substitute them back into either equation. I'd recommend the linear equation myself, to determine what the y coordinates would be at those points of intersection. And once you've done that, you've found the coordinates of the points of intersection.